Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. Problem 3066, minimum operations to exceed threshold value 2. In this video, we are going to explain again how to use data structure to solve coding problems. So here we are going to use heap. Actually, it's very natural based on the problem statement. Let's quickly look at the problem statement. So here we are given an array called nums and an integer key. So in that operation, we can take the two smallest integers x, y in nums, and then remove them and add another integer back. But the one added is the 2 times the minimal of the 2, and then plus the maximum. So anywhere in the array. Actually, this anywhere does not play much role because each time we need to take the two smallest integers, right? So actually, this just to make the problem confusing for the problem solver, I would say. So note that you can only apply the described operation if nums contains at least 2 elements. So actually this condition will correspond to a condition check in our while loop. So we want to return the minimum number of operations needed so that all elements of the array are greater than or equal to the threshold value key. So if you look at example 1, so you can see this is 2, and example 2 is going to give you 2. So first time you get 1, 1, and then you add back 3. Then 3 and 2, you get out this 2, and then you get 2 times 2 plus 3, 7 back. Then 7 and 4, you get 7 and 4, 4 times 2 plus 7, 15, right? So you get 15 and 9. So then you get 15 and 9, and then you put back 9 times 2 plus 15, that is 33. 33 is greater than 20, right? So that's the 4. So here, this is the length, right? So basically, this gives us the problem size. And the nums are positive integers. And the input is generated such that an answer always exists. So this is actually an important one, which has something to do with our coding format or return format. So without further ado, let's do some annotation first and then go to the coding. So we are going to use data structure to solve problems. So here we are going to use heap. This is actually very natural from the operation, right? It takes the two smallest integers in nums. So with that said, now let's look at the coding. First, I'm going to make heapify this nums, right? So make nums a heap, and then I'm going to set number of operations to be 0. So this will be a counting variable, right? Then we are going to have a while loop. While the length of nums is greater than or equal to 2, right? And also we want to know the smallest number in the heap, which is always the heap root. So nums 0 is only if it's less than k, then we consider the operations. If it's already greater than or equal to k, right? Then we just need to return the state of the number of operations. So the condition will be the same. You have m, so you get heap q, heap pop from nums, right? So then because the length is greater than or equal to 2, we can do another pop operation. So you're going to have heap q, heap pop nums. So maybe we can see small, large. So that may be better. So now what we want to put back is heap q, heap push. So we push back to this heap, and the element we want to put back is 2 times small plus large, right? Then after we exit this while loop, then either this condition is validated or this is validated. However, due to the assumption here, so we know we always have this one, then what we are going to return is just the and operations. That's actually the code for this problem. So now let's quickly do a run. It's wrong. Let's see what's the problem. So I think here I forgot one important line. So this is the operation, right? Do the operation, and then we need to increment the count, right? Increment the count. That is n ops incremented by 1. Now let's run it. Yeah, it passes the 2 test case. Now let's look at the generic cases. Yeah, it passes all the cases. So here, I guess we are using heap, which actually is induced from the first bullet item in the operation definition. So with that said, I guess that's it for the current video. Thank you for watching.